So we are looking at what is a monomial. So a monomial can be a number, a variable, or a product of number and variables. A number, a variable, or a product of numbers and variables. So, for an example, -5 is a monomial, but also -5xy is a monomial. Just m, that would be a monomial. M cubed is a monomial. Now, a polynomial is the sum or difference of two or more monomials. So a polynomial is going to have monomials, and it's going to have addition or subtraction throughout. Okay? So, parts of an expression. We have different terms. In this case, we have 3 terms, 3 monomials. So our monomials here are 5x squared, -8x, and 4. Now, we have some coefficients. Coefficients are the numbers that are being multiplied with the variable part of the term. So, one of our coefficients is 5, and another coefficient is -8. Okay? Now, we have variable terms. We have identified the coefficients. Now, that 4, what does that 4 represent? What is that called? A constant. So the 4 is a constant. Now, when we look at this polynomial, can I add and subtract those pieces together? Why not? They're not common terms. They do not have like terms. So, with that being said, to add or subtract polynomials, you combine like terms. Combine like terms. In addition, I find this to be easiest because you just combine what you see. We will look at subtraction as well and how it's a little bit different. So, we're looking at example 1, combining like terms. What is the like term with 5x squared? 2x squared. So 5 plus 2 is 7x squared. I do not change the exponent. Then we have -8x, and that can combine with 4x. So -8 plus 4 is -4x. So we write that as a -4x. Okay, lastly, we have plus 4 that can combine with plus 7. So 7 plus 4 is 11. So here is our answer. You know you're finished when you do not have any other like terms. You're good. You can't combine anything. Yes.
Oh, we did these before, something like this in the beginning?
Yes. It's very similar. Pretty much exactly the same as what we did before as far as the addition and subtraction. But when we get to the multiplication, the power rule, and division, it'll be different. So now, example 2, what do we notice between the groups? Subtraction. So when you have subtraction in front of parentheses, you want to distribute that sign, meaning everything inside the parentheses, the sign will change. That'll become a minus 5x. That plus 9x squared becomes minus 9x squared. The minus 6 becomes a plus 6. Now, I show that because it really helps to distribute that minus through so you don't forget. And then once you do that, you can combine like terms. So, looking at the positive 7, what can I combine with 7? 6. And 7 plus 6 is 13. Then we have positive 8x. That was a plus 8x. And that can combine with a minus 5. Positive 8 minus 5 is a positive, so plus 3x. Then lastly, we have 2x squared minus 9x squared. So 2 minus 9 is negative 7x squared. Okay? So now, looking at multiplying monomials. When we multiply monomials, we follow something called the product rule. Does anyone remember what the product rule tells us to do with our exponents? The product rule tells us to add exponents. So that would become x to the a plus b. Now, you can only add exponents when the bases are the same. What I mean by the base is that's the number or the variable that is in front of your exponent. So in this case, the base is x. So since they both have x, we can add exponents. Okay. Did you have a question? Okay. Looking at number 3, my base is a. I have a for 3 different pieces. And my exponents are 2, 3, and 1. So when I add my exponents, that's 2 plus 3 plus 1. And that is a to the 6th. Okay? Now, example 4, notice we have 2 different bases here. We have x's that can go together, and then you have what? Y's. So for the x, what are the 3 exponents attached to the x? 7, 4, and 1. That x here without an exponent is a 1. So that becomes x to the 12th power. Then we have to look at the y. The y has a y cubed and a y to the 5th. So we're going to be adding the 3 and the 5. So that's y to the 8th. Y to the 8th. Okay? So that is when you just are looking at the monomials without coefficients. Now we want to look at multiplying monomials that have coefficients, meaning it has that number that's being multiplied by the variable term. So we are looking at example 5. So when you have coefficients, you multiply the coefficient. So here we would have 3 times 5. And it says simplify the variables following the product rule. The product rule says add exponents. So I look at my x, and what are the exponents? 4 and 2. So that becomes x to the 6. That would be our answer. 15x to the power of 6. That's it. Yep. That's it. Nothing else. Nothing. Nothing else. Okay, number 6. When we're looking at the coefficients, we have a 2 and a -5. So 2 times -5 is -10. Now, a goes with a. So that's a, and then 3 plus 5 is a to the 8th. You add. It is, oh, that's a 9. I apologize. And then it will be 12. My apologies. Okay. Now for the b. For the b, we have b squared and b to the 6. So that would be 2 plus 6, which is b to the 8th. So that is the answer. Are we going to divide? Yes. We're going to do this whole, this is all today. Yeah. All right. Use the power rule when you have an exponent raised to a power. That means you have 2 exponents together. You're saying that x to the a is raised to the power of b. So, the power rule tells us to multiply exponents. Multiply exponents. So that would become x to the a times b. X to the a times b.
So, for example, you would do 3 times 4, and that would be x to whatever that is. Then
Yeah.
y would be 2 times 4.
Yes, so x would be x to the 3 times 4, y to the 2 times 8. So that would be x to the 12th, y to the 16th.
Where'd you get 8 from?
It's 4, but I know, I messed up. Thank you. That would be 2 times 4. My brain, I was thinking the 8 as I was doing it before I wrote it. I need to slow down in my head. Let me make this a little thinner. Alright, so for example 8, the a to the 6th, you're going to multiply by 5, and the 6 times 5 is 30. Now currently that b is to the first power, so 1 times 5 is 5, so that's b to the 5th. And then C, we would have 2 times 5, which is C to the 10th. So that's when we don't have coefficients. Now, sometimes you're going to have coefficients. So the difference is when you have power to a power with coefficients, you want to raise the coefficients to the given power, then apply the power rule, which was to multiply exponents. So, looking at example 9, that 3 needs to be raised to the third power. So that's not going to be 9. 3 to the third power is not 9. That is 3 times 3 times 3, which is 27. Then we have M, and that is going to be 5 times 3, which is 15. Then N to the 6th raised to the third power becomes N to the 18th power. N to the 18th power. Okay. Example 10. That negative 2 is the coefficient, and it's going to be raised to the 4th power. Negative 2 is going to be raised to the 4th power. That is not negative 8. Negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2, which gives us 16. And if you put negative 16, that is wrong. We've already learned we learned rules for multiplication. So I expect you guys to apply that. All right, now looking at our variables. X cubed raised to the 4th would be x to the 3 times 4, which is 12. Now, for the y, that's 1 times 4, which is 4. And then lastly, z squared raised to the 4th is z to the 8th power. Okay. So now the quotient rule, which someone was asking about, division. In division, do we remember what we do with our exponents? So in multiplication, what did we do? In multiplication, we added exponents. So in division, we're going to subtract exponents. So x to the a divided by x to the b is x to the a minus b. Now, you can only do that with your common basis. So x goes with x. A y would go with y. If I had a w, it would go with w. Okay, so looking at example 11, we have our x's. So that's going to be 8 minus 5. What would the y's become?
4 minus 3.
4 minus 3. And z is 3 minus 1. Now, I did hear someone, they were giving me the answer, and that's fine. So this would be the final answer. X cubed y z squared. Okay, now looking at the next one. A. 9 minus 1. So that would give us a to the 8th. Now B, right now B is a 1 and a 1. So that cancels the B out. And then for my C's, I have 5 minus 3, which is C squared.
So since B is 1 minus 1, you just cross out your variable.
Now, because this kind of just popped in my head, what if we had, I want us to look at this. It's not on your paper, but kind of look right here with me. What if I had a to the 4th b squared c over a to the 4th b squared c? So they're all going to cancel out, and my answer is not 0. Because it's numerator with the same denominator. What does that give us if everything cancels out? Think about 5 over 5. What is 5 over 5? 1. So this over itself is 1. If everything cancels out, it is 1. Sorry about that.
Would you accept 1 over 1? Because I might mess around.
But when you go to Math 103, they might not. Are you taking that next semester?
No.
Oh. Depends on who you take it with. Who is taking 103 next semester? You gonna wait?
Let's get it over with.
Well, honey, you have to take another math. Okay, like I just want to make sure, like this does not fulfill your general ed requirement. All right. So now the quotient rule with variables, we have to divide the coefficients and then subtract exponents. Divide coefficients. So in example 13, you're going to have 15 divided by -3, which is -5. Now sometimes when you divide, you'll get a fraction. But in this case we got -5. We're going to look at a couple from the homework in a little bit where you get a fraction so that we can practice that. So now with our variables, we just apply the quotient rule. So for my x, that would be 7 minus 2, which is 5. For the y's, we have 2 minus 1, which is y. For the z, we would have 9 minus 6, which is 3.
Maybe I missed it. Is there anything about putting y to the first power as an answer?
It's not fully simplified. Again, that's one of those things I would be okay with, but it really just, moving forward, they might expect you to simplify it without the exponent on it. Kind of like when you have an answer that would be a 1x, it's not fully simplified unless you write it as x because of that identity property. Like if you had 1y, we would just write that as y. For me, it's not make it or break it, but you know, it truly isn't fully simplified until you do it. Okay, example 14, we have negative 24 divided by 6. Negative 24 divided by 6 is negative 4. Now, for the A, we have 8 minus 8, which cancels. For the B, we have 7 subtract 3, which is 4. And for C, we have 3 subtract 2, which is C. Negative 4, B to the 4th, C. And what Aaron was asking before was if you had that 1 there, it's not wrong. It's just when you see me do it, I'm going to take the 1 off to fully simplify. So now we have 4 on this to try. Now we've gone over all the rules. They're really, it was pretty straightforward. You just have to learn the rules. This is one of those things that Desmos cannot do. It's not going to do it for you. You can't go to Desmos and type in 4p squared minus 2p and it's going to give you the answer. You have to know your rules. So, looking at this first one, is this an addition, subtraction, multiplication, or division problem? Subtraction. So that tells me I need to distribute the minus. So that 2p becomes minus 2p. And what does that 5p squared become? Minus 5p squared. So now we combine like terms. What does the 4p squared combine with? Negative 5p squared. So that's a negative 1p squared. Then, what does the positive 3p combine with? A minus 2p, which then is plus 1. And then that constant comes down. Now, if you left it there, you didn't do anything wrong. I am going to fully simplify. Take my coefficient of 1's out. Because the identity property tells me that 1 times p is p. Negative 1 times p squared is negative p squared. Now, number 2, what operation is going on here? In number 2? Number 2, I have something beside another something. So this is multiplication. This is the multiplication rule. And so the multiplication rule tells us to multiply coefficients. So 4 times negative 3. And what do we do with exponents? We add our exponents. So x becomes 1 plus 4. Y becomes 3 plus 5. And then the z doesn't have anything, so it just comes down. Okay? Now, this next one, what rule are we going to be applying? This is a power rule because you have something, a monomial raised to an exponent. Okay? -2 is going to be raised to the 4th. M to the 4 times 4, and N to the 3 times 4. Now remember, -2 to the 4th is not -2 times 4. It really means -2 times -2 times -2 times -2, which is 16. And then multiply your exponent, m to the 16th, n to the 12th. Okay. Number 4, this is the division rule. So you would have 12 divided by 6. You divide the coefficients, but what do you do with your exponents? Subtract. We subtract exponents. So that gives me a cubed b to the 6. And what happens to c? Cancels out. So in all of these rules, if it's multiplication, you multiply the coefficients. Division, you divide coefficients. Power rule, you raise the coefficient to a power. What's different is what you do with the exponents. But I try to remind myself, okay, multiplication is a series of addition. So multiplication, series of addition, I'm adding exponents. The opposite of multiplication is division. So what's the opposite of adding exponents? Subtracting exponents. When I raise something to a power, what am I really doing to that thing? Multiplying it. So power rule, I multiply my exponents. It really makes sense if you understand what those operations actually represent. If you understand multiplication is a series of addition, okay, we add exponents. If you understand the opposite of multiply is divide, then that should make sense. I'm going to be subtracting my exponents. It's just number sense and applying all of the little things you've learned even since you were little. And for some of us, you know, we forgot those things, and it's okay, but the more we can pull in what we've already learned and remember that, the better you'll do. So then, there is this homework, and it is going to need to be done, but there's some of it I want us to do together. So if we're looking at the adding and subtracting, so I'm going to go ahead and write in here, complete for 11, what would be 11:7, but we're going to do some of it right now. But what we don't do, you'll do on your own. So the first one I want us to look at is number 4. So the first one we're going to look at is number 4. I see something here that since the very beginning of this class has bothered me. What is it? Yes, the minus a negative. So I'm going to change that minus a negative to a plus. So now, What is negative 14p plus 14p?
0.
0. So this is 0. We're done. Okay. Let's look at number 6. All right, number 6. Are these like terms? No. So, if they're not like terms, I cannot add them. So, the answer is what it is. You can't do anything here. This is your answer. You can't simplify it. Okay? Let's look at number 9. So number 9, we have 13c squared d. I can only combine that with a term that has a c squared d. It has to be c squared d. So I look, what other term has c squared d? Yes, so I can combine those. 13 minus 7 is 6. C squared d. Okay? Then we look at the next term. We have plus CD squared. So that's really what kind of CD squared? A 1. So I can combine that with a minus 11. So 1 minus 11 is negative 10. So I'll write that as a minus 10 CD squared. Your exponents have to match for them to be like terms. We can't just put all of that together because they have a C and a D. It has to be the same sequence of variables. All right. So now the wordy ones. Let's look at number 10. So in number 10, it says subtract negative 7y. So it's telling me subtract a negative 7y from negative 10y. One little thing I like to think of, because people always want to mix these up. They want to put the negative 7y first. It says I'm subtracting from something that's already there. So I have to start with what's already there, and that was the negative 10y. So usually when there's a from, whatever comes after the word from is going to be first. Okay? Because it's saying I'm taking something from that, what's already there. If I'm taking $5 from you, then I'm subtracting the 5 from whatever you had. Looking at 11. From 15r squared s, so from this, we want to subtract the 19r squared s. So the 15 is going to come first, because from this, we want to subtract the 19r squared s. Like from $20, I'm going to subtract 10. So I started with the 20, and I'm subtracting 10. Number 12 says subtract m squared n from negative 8m squared n. So I'm subtracting m squared n from something that's already there. In this case, it's negative 8m squared n. And we can simplify these. I really was just setting them up, but we could go now and combine. Negative 10 minus negative 7 would become negative 3y. Number 11, when I combine, that would become negative 4 r squared s. Number 12, that would become negative 9. And so what you would see is if you didn't write this correctly, you wouldn't get the correct answer. Because negative 7 minus 10 would have given us a negative 17. Why? So it is important, like it does matter in subtraction, the order you write things. Alright, so then the rest of this addition and subtraction, you can practice on your own at some point between now and Thursday. It does need to be done. Okay, for multiplying. Now, multiplying is going to be a big one because Thursday we're going to be looking at multiplying binomials. If you can't multiply monomials, you're going to have trouble with the binomials. So, with that being said, when I say multiplying binomials, back if you learned this in high school, y'all probably called it FOIL. The FOIL method, you use that. So that's what we'll be doing Thursday. Then we're going to be well on our way to start our factoring. We'll do factoring, quadratic formula, and then that'll be it for new stuff before the final. So, looking at multiplying, if we remember in multiplication, we multiply coefficients and do what with our exponents? Add. So let's look at number 17. Now we're not going to do all of these together, but I do want us to look at a couple. So 17, I have 3 different coefficients. Some of you might be like, I only see 2, but trust me. We want to multiply the 13, the 2, and a negative 1. When you have that negative, that's a negative 1. So, doing that, I get negative 26. Now, when we're looking at our variables in multiplication, what do we do with our variables? Add. So the P is going to have a 3 plus 1, so that's P to the 4th. And for our Q, that's a Q to the 1st and a Q to the 5th, so that's Q to the 1 plus 5, which is Q to the 6th. Okay? You feel good about that?
Yep.
Okay, let's look at number 19. In number 19, our coefficients are negative 6 and negative 1/3. When I multiply that together, 6 times negative 1/3 is 2. Now, what are my exponents for A? 1 and 1, so that's 1 plus 1, which is A squared. And then for B, we have B to the 9th and B to the 4th. So that's B to the 13th power. Okay? Let's look at number 20. Alright, so what are my coefficients? (15 4/3). So 15 times 4/3 is 20. Okay, what are my exponents for the P? 5 5 plus 2, so that's p to the 7th. What about for my q? 1 and 1 makes 2. Yep. So q squared. And r is going to be a 7 plus 1, which is 8. Okay, we feel good with multiplying? Multiply, you multiply coefficients, add the exponents. Then we have the power rule. So, for the power rule, let's look at, let's look at 7. We'll probably look at 7, 8, 9. The power rule tells us the coefficient is raised to the power. And then your exponents, we multiply our exponents. Negative 5 cubed is not negative 15. Negative 5 cubed is what? Right. Negative 5 times negative 5 times negative 5, which is negative 125 y to the 9th. No. Negative times a negative is a positive, times a negative, which makes it negative. Odd powers, you keep the negative. Even powers, it becomes positive. Okay, number 8. What's the coefficient in number 8? Negative 1. So I'm saying negative 1 to the 4th power. The A is to the 9 times 4. And B is to the 1 times 4. Negative 1 to the 4th is positive 1. Multiply exponents. A to the 36th, B to the 4th. That's just A to the 36th, B to the 4th. Looking at number 9. This is 1/2 to the 7th power. And then for x, we have to the 4 times 7. So 1/2 to the 7th power, you raise the numerator to the 7th power, which is 1. And then 2 to the 7th power is not 14. So that's 2 times 2 times 2 times 2 times 2 times 2 times 2, which is 128. Now you could do 2 to the 7th in a calculator. And then the exponent would be 28. Alright, so power to a power. And then lastly, we're going to look at division. So in division, what do we do with exponents? Subtract. So let's look at number 2. We talked about this. When you have something divided by itself, it cancels out and becomes 1. Okay? Now, next ones we'll look at, let's look at 6. We'll look at 6, 10, and 11. So number 6, we might do another one. Number 6, what do I do with that 8 and 4? Divide. What's 8 divided by 4? 2. What do I do with my exponents? Subtract 5 minus 2. And for the y's, that would be 4 minus 2, which is 2. Alright, looking at number 10. Number 10. 21 divided by 27. Now, that is not going to give me a whole number. It's going to give me a fraction. What can I divide out of 21 and 27? A 3. So that becomes a 7/9. And now subtract exponents. So 8 minus 5 is m cubed. And n, 5 minus 4, is just n. It's n to the first, which is n. All right, looking at number 11. Now, I set this up, and we do negative 15 divided by 45, and it is not negative 3. Every time somebody tells me it's negative 3. It's negative 1/3. Then, for your x, 5 minus 1 is 4. 4 minus 3 is 1. So there we are. Let's go ahead and look at 12. Okay, for 12, you start with 7 divided by 14. It's 1/2. It's not 2. Now, what happens to the p squares? Yes, it's 2 minus 2, which cancels out. What happens to my cubes? They also cancel out. So my answer is 1/2.